All right, so we got to start first by talking about what is a function. Okay, so function is a kind of a big scary word, but it's something that you guys already kind of understand on an intuitive level. Okay, so if you would like a nice formal definition, a function is a rule that assigns each input value exactly one output value. That's the formal definition. Okay, so a function is a rule that assigns each input value exactly one output value. What does that actually mean? So that sounds super complicated, but in reality, it's a pretty intuitive thing to understand. Okay, so I want you to imagine a situation where you and your friend are sitting there and your friend says, "Hey, I need you to do me a favor." And you're like, "Okay, fine." Your friend says, "I'm going to give you some values and I want you to tell me what happens to the number after you triple it and add 1." And you're like, "Okay, fine." So what your friend does is they say, "I'm going to give you some input values and I want you to give me some output values." And you're like, "Cool." So triple it and add 1. It's like, "Okay, cool, fine, that's easy." So your friend says 4. And you're like, "Okay, well, if I triple 4, that's 12. If I add 1, it's 13. That's easy." How about 6? If I triple it, that's 18. If I add 1, it gives me 19. Triple it and add 1. How about -2? So triple it, that would give you -6. Add 1. -6 plus 1 is technically -5. So on and so forth. That is a very simple example of a function. So your friend gave you an input. You gave him the output. The function here, in this case, is just the rule that tells you how to get from the input to the output. Okay? So the function here, if we were going to say it in words, we would say triple it and add 1. If we wanted to use symbols for our function, what would we say? We would say, well, the function is, we would say, usually we call it f of x, probably f because of function. So this is right here, we say that this is the name of the function. This thing right here is the input. For some reason, we just like using the letter x. Like we could put in anything we want here. We could have put in red triangle if we wanted to. But we like to use x as the input. So get used to that. And the output is what comes next. So whatever you write here is going to be your output. In our case, what's the output? What is the rule here? How would we express the rule if we were just going to use symbols here, like letters and numbers? We would say that the output is 3 times the initial input. The initial input was x, right? So we would triple that. We'd say 3x. And then how do we communicate adding 1? Well, literally just plus 1. Okay, so this is right here. This is called the symbolic notation of a function. Okay, so literally a function is just the rule itself that tells you how to get from the from the input to the output. Okay, and functions will take many different kinds of forms. So I just want to give you examples of like everyday functions, because at first you're kind of like, well, this is weird. Like, why is this so important? Why do we talk about this? Why do my Algebra 1 and Algebra 2 teachers make such a big fuss out of this? And the reason is because functions are everywhere. Okay, so we've got many forms of functions. And I'm just going to give you a few examples. There are many more that I haven't listed that are awesome that I just didn't think about because I didn't want to spend more than 20 minutes thinking about it. Okay, so we, like, a lot of times we just have simple things like double something. Okay, like if you're going to have 20 people over for a cookout, how many buns are you going to need? You're going to need 40 buns because if you're going to have hamburger buns, you have a top and a bottom. So technically you'll have double the number of people. So that would be a useful scenario where it would be helpful to know, hey, the function here is super simple, just double it. Another example is paying for something. So when you pay for something, you're charged a tax. So when you buy something, right, and this is so annoying, when you see something at the store for $9.99, you don't actually pay $9.99. You pay like $10.56 or $10.57, depending on the exact tax rate. And so what you may have is the amount that I pay. So maybe you would call it P of X. You could name your function P for pay. What would P of X be? P of X would be, it'd be a little bit more than what the price is. So you have the pay amount, that's P, and then X was the initial price. So like that X right there is the initial price. What would you actually have to pay? It'd be 1.0575 times X. So I'll just put them in parentheses there. A lot of people don't put them in parentheses. They'll just say 1.0575x. What that means is whatever the initial price was, that's X, you would just pay 1.0575 times that. And that's just the sales tax in Ohio, for the state of Ohio. Okay? So that's an example of a function. Number 3, so knowing the average height of a child given their age. So we'll just say average height of child given age. So your input in this case would be your age, right? So like let's say you're 14 or 15 and you're going to the doctor. I don't know if you guys have ever done this. When you go to the doctor, they like tell you what percentile you are. And what they're saying is what percentage of people your age are below you, like in height. So if you're in the 40th percentile, that means 40% of the people your age happen to be shorter than you, and 60% of the people your age happen to be taller than you. And so a doctor, it would be really helpful for a doctor to know, hey, given a 9-year-old, what is the average height of a 9-year-old? So what you could do is you could make a table and say, if you're 8 years old, the average height is, I have no idea, 51 inches or something like that. I have no idea. I'm just making that up. But if you're 9 years old, the average height is 52.5 inches. And so as you get older, the average height will tend to go up. But only for a certain amount of time. Then apparently once you get older, you actually shrink a little bit. What are some other places you might see functions? So number 4, converting money. So if you guys have ever traveled outside the US, you'll know that they use different forms of currency. They don't use US dollars. Like if you go to Europe, you may have to get euros. And right now, 1 euro is approximately 1.17 US dollars, which I'm just going to mark USD instead of putting the dollar sign. I probably should put the dollar sign. So if you were going to make a function to model this, like let's say you go over to Spain and you've got, well, actually, let's do it the other way. Let's say somebody from Spain comes over to the United States and they bring over 100 euros. They would want to know how many US dollars they were going to get. And so you could make a function out of this. You could call it maybe USD of X. So this is the name of the function. This is the amount of euros that you're bringing. And so the amount of US dollars that you would get is 1.17 times X. Right? So if you wanted to know, hey, if I bring over 100 euros, how many US dollars would I get? You could do 1.17 and you could just multiply it by 100 and you would get 117. And so that's how they figure out how much money you get when you come over and convert your money. And here's an interesting one that might be a little more relevant since it's fall. How many hot dogs to buy for a summer cookout? So we'll say how many hot dogs to buy for a summer cookout. And that's going to be given the number of people that are planning on coming. Okay, so your input in this case is the number of people that are coming. The output is how many hot dogs to purchase. Now, here's a question. If you think about this, what do you think would be a reasonable amount of hot dogs to purchase per person? So would you get half a hot dog per person? So if you had 100 people, you would only buy 50 hot dogs. That would be not enough, right? We're kind of assuming that maybe not everybody, but most people are going to eat a hot dog. And in fact, most people, maybe not most, but a lot of people are going to have more than one hot dog. If you're like me, who loves to eat, maybe I would eat 2 or 3 hot dogs, which is actually false because I don't really like hot dogs. But so you may need to consider not only how many people are coming, but like how many people are adults and how many people are kids. And so to create a function for this is actually slightly more complicated than some of our other examples. Maybe you land on something like this, where you say, f of x is going to be equal to 1.8x. So we'll just assume that if x is the number of people showing up, so that's the number of people, then the amount of hot dogs I should get is going to be 1.8 times that. So we're assuming that most people will have a hot dog, and that in addition to most people having a hot dog, actually a lot of people are going to have 2 hot dogs. Not everybody. If everybody was going to have 2 hot dogs, we would make it f of x is equal to 2x. But as it is, we'll assume that a lot of people are going to eat 2 hot dogs. Okay, so these are just some basic examples of functions and why you might need them. Okay, we're going to deal with lots of different functions this year. So we're going to deal with things that create lines. So like 2x plus 1. We're going to deal with things called parabolas. So parabolas, like x squared plus 2x minus 3. And what's cool is that when you throw something in the air, it falls, and the shape that it creates when it falls over time is a parabola. So we're able to actually predict where something is in space given where it started and how fast it was going when you let it go. We're also going to talk about square roots. So square roots, so like 3x minus 2, like the square root of 3x minus 2. We're going to talk about rational functions this year. So 2x over x plus 1, stuff like that. And those are kind of weird. You guys are also probably somewhat familiar with absolute value functions. Okay, so absolute value functions, which look like this. So the absolute value of 2x minus 1, stuff like that. And we're also going to deal with exponential functions. So things that grow exponentially. So you might have something like 3 times 2 to the x. Okay. Last thing I want to talk about with functions is the idea of what we call domain and range. Okay. So if you consider all of the possible input values of a function, okay, so before I finish this sentence, I want you to think about this. If we go back up to our example, up here, right? So the average height of a child given their age. So the input value is going to be the child's age. What numbers might make sense to put in for a child's age? Would it make sense to put in 5? Sure. Would it make sense to put in 7.5? Sure, maybe if you're 7.5 years old. Would it make sense to put in -3 for a child's age? No, that wouldn't make sense, right? Would it make sense to put in 400 for a child's age? I don't know anybody who's ever lived that long, right? So probably not. So there's a limited amount of possible input values for some functions. Some functions don't have a limit on their input values, and we would say that You can put in anything you want. You could put in literally any real number, 4.7, negative 3.2, right? But if you consider all of the possible input values of a function, this is called the domain. The domain. Okay? And that, I realize that is a fairly abstract concept, but it's really, we're going to talk about that a lot. Okay? So the domain of a function is just literally anything, like the collection of all of the possible numbers that you could put in to the function. So maybe for our example, like the average height of a child given their age, let's just define a child as somebody between the age of 0 and 18. So the domain of that function then would be any number, including decimals, between 0 and 18. Not including 18, right? So you can be 17.999999, but you couldn't be 18, okay? That is the domain of a function. The range of a function, okay? So it's the same idea. If you consider all the output values of a function. So we've considered everything that we could possibly put in. Now I want to switch gears and think about what are all the numbers that could possibly come out of a function. This right here is called the range. So let's go back to our example with the kids. If you think about the height of a child given their age, what are possible heights? Like, what could we possibly get as an answer? Like, if I supplied you the age of a child, what might somebody tell us as the possible height of that child? I'm going to say, so if we assume that a child is 0 years old, so like let's say conception, okay? When you're very first conceived, your height is essentially 0, okay? But I'm going to say that there's a limit there is an upper limit for how tall you could possibly be, right? You couldn't have a child who's 17 years old that's like 9 feet tall. Maybe that's possible. I've never heard of that. Right, so this function is limited on the output values probably to something between 0 and 7.5 feet. I don't know how tall like the tallest people are, right? But that's the range. So the range for that function would be anything between 0 and 7.5. Some functions have ranges that are limited from, only positive numbers or only negative numbers. Some functions, the range is every real number. Like, eventually, if you plugged in enough inputs, you would get every real number to come out of the function as well. Okay, so that's a quick intro on functions and the kinds of functions and domain and range.